on a positive note, before I leave, I'm going to ride that big slow merry-go-round in the sky over there. It's just too beautiful. There is no wind here and that thing is still turning. Can't believe it. Boomtown Laboratories. Kind of a neat effect. That's off the window. Anyway, LEDs. Putting out a lot of light. And way over here, looks kind of like a sound stage, but that's the underside of the solar panels. You have light in all different directions. Pretty decent light to work under. I worked pretty well under there. I did a lot of connections. Actually, I did 40 connections because there's 20 solar panels, 2 wires on each solar panel. Anyway, got all that done. And on top of that, I went over here, and there's the end of the wire. That's 4 strands of number 12 Romex wire right here going into the conduit. The conduit runs all the way over the top of the porch here, and all the way over here, and all the way out to here. That was a lot of pulling. I got a workout too, I mean. Okay, now that they're done over there at the cement, see my Romex is running way up over there to where the other box is going to be. And coming back, and I got a box sitting right there, just to the right side of the little spray cans. It's going to lead one off going over here with this box is going to be there. The other box is going to be up over there somewhere. Alright, and it comes around, got a nice curve. I put that in with a bicycle wheel. I have to extend from this box right here out over to there and then back over. So that means I'm going to make one more curve. I did this one with a bicycle wheel. Alright, we got a little dust on the panels here. It's alright. Like we said, 1, 2, 3, 4, 5, which I've got them numbered underneath. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I haven't numbered these yet. I'm going to number them in the same fashion, starting with 11. Those ones over there that are 1 through 5, I'm going to have on L1. L1 is the black wire that you see inside your conductors. L2 is the red. And if this was 3-phase power coming to this place, it would be a blue one for L3. But anyway, I'll show you the label underneath these things. These were 78 cents per watt, 205 watts a piece, but pretty close to about $4,000. Ay. 78 cents a watt though. A whole lot better than $4 and $5 a watt. Right here it says Evergreen Solar. Peak power, 205 watts. Maximum peak power, 209.9, almost 210, but I don't think we're going to see that. Okay, got planes flying over interrupting the video. Almost feel like Dan Rojas. Minimum peak power, 205 watts. Voltage at peak power is 28.5 volts. That's where the inverters start their power. And current at peak power is 7.21 amps. That's very important. That tells you your wire size. Well, on this system I decided to go with a little bit thicker wire than needed just to make sure the voltage travels. Then open circuit voltage 35 volts. That's when the sun's shining on it and you've got it unhooked from everything and you're just measuring the voltage across the panel. And then when you short the circuit, the current 7.91 amps, 7.9 amps, that's shorted straight through the meter. Anyway, if you look right here, it says cosmetically imperfect. At 78 cents a watt, that's not a bad deal. Let me show you what cosmetically imperfect is. There we go, it's a beautiful panel. I'm going to look right down here. This one got chipped and it slid sideways. You can see the edge right here. That's not something over the edge of the panel. You notice how this edge is sitting out just a little bit farther, so this one here got taken out this far. And that's cosmetically imperfect. This is the only one I found the cosmetically imperfect part on. All these over here, it's going to take a little bit of looking to find them. Have no idea what the cosmetically imperfect is. Maybe it could be that these don't quite line up perfect or something right here. This, just basically the only thing you got to know is it's 205 watts each. There's over 4,000 watts worth of solar panel up here. The grid tie inverters are 1,200 watts each. I got 4 of them. One for that one for that set, one for that set, one for that set, and one for that set over there. I'm running each panel to the grid tie inverter on 12 gauge wire. Each connection is separate. Okay, show you what I've done. Well, I've got the electrical hooked up. I'll show you all that in a little bit, especially when I get onto the other one. I've already got these plugged in, and these are powered off. So, and I've got all the solar panels already rigged up here. When I was in sign work, we had to do what we called a drip loop. That's where it comes down and then comes up. That means the water will drop off the end of the loop and never make it up to the connection. It keeps your connections dry. That's in all sign work. Also, I painted the heat shrink when I stuck it on each one of these, and then I made my connections. I showed you the connections, and then I slide it over the connections after I'm done crimping, and you can't tell that it's not the same piece of wire. And this is completely sealed. I've got it tie wrapped up high, that way the drip loop keeps the water off of everything. And I've got them grounded on these screws right here. There's a better shot of that one over there. All the ones over this way on down are 1, 2, 3, 4, and 5 solar panel, and then I've come over here 6, 7, 8, 9, and 10, and this is the first two coming to here, and I've got those all the way down there. I've got those wired just a little different without the grounds, because it's all grounded through the system, through the screws and all this other stuff. I'm also going to add another ground. I've got a ground down here that jumps over to the ground on the box, which is already grounded through the plug, which I tested with the ohm meter and they don't seem to be connected. Got one more ground down there, and then it goes out here to a drip loop, and it's going to connect to the bottom of this rail on the big bolt. So far that's what I've got. I've got all these 1 through 5 coming through here, actually 1 through 3 coming through here, and they come up over to here. This is for the next set of solar panels. This is 6, 7, and 8 right here. That's those 3 panels here, and then these first 2 right here come down, and they come all the way across over here. Everything's got a nice drip loop. I've decided to, oh, there goes my glasses. We'll have to get a magnet to get them. But anyway, all the drip loops come down, and it's all going to drip into here. And I got my drip loops there. I still haven't heated the heat shrink here. I kind of use the holes here to keep the order of the panels. And so that's where I'm at on this set over here, and then I'm going to go to the other set, and you're going to see a little bit more over there. I'm Scott Brown with Green Wind and Other Home Energy. Many good things to you and yours. Something else to notice, you see these little barcodes right here with that, I forget what they call that, but it's 86 blah 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 40506. This is not the product number. There's more of them all the way down on each of them. Plus, right here, we're looking at 860 blah 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 40506. Look at the one over here on this side. You notice it's a different number. So this is not a product number. This is your serial numbers. These panels can be traced. They can take a picture of that with their iPhone and track these things. It's a good thing to record all of these numbers. Keep your packing slip. It should have them on it. If it doesn't, then write them all down. This is in case they ever get stolen. Okay, we're looking down at the conduit. I've got 2 cables of 12 gauge wire running through here, 4 conductor, ground to neutral, red wire, which is the L2, and L1, which is the black wire. And that's 2 cables setting through here. This steel conduit. Not really meant for outside, but we're going to seal these joints with a bunch of silicone and encapsulate it. This bend here that you see in the conduit, that bend in the conduit was done on the rim on this table, that little handle that rolls the cart around. I stuck the conduit on top of the handle there and bent it up around the rim until I got it to that curve right there. I'll show you another way to bend. This bend right here was done with a bicycle rim. Stuck the bicycle rim up against 2 pieces of angle iron on a trailer. The other end of the conduit was stuck into the next post, and I just pulled it around and bent it. That keeps it from kinking. Another way you can bend if you really have to. Did these purposefully. You can see it's got a kink here, a kink here, a kink here, and a kink here. This was done on a vise, and then I squoze it on the sides and did this. What I did is I measured how far over this way that it would line up straight where I got the box mounted, and how far I had from here to here to make that bend in. So I made a bend here and bend here, and I measured over. Looking straight down here, I measured from here over to here to see if it would fit. It came up here, and she fit in beautifully. Came in here, and I cut it off. This box is sitting a little bit farther back, so when I pull the box up, but for right now, I'll leave it right where she's at until I hook up the receptacle box. So this one's all getting ready to get wired up. You're going to get to see a lot of this. So I'm just going to start pulling the wire and hooking it all up. 1200 watt grid tie inverter. We're using about 1000 watts, so we're not peaking it out or maxing it out. These are about anywhere from 80 to 85% efficient. So out of the 1000 watts, he's going to get probably about 800 watts a set coming out. So that'll be 3200 watt unless it peaks up a little higher, and that's going to make a nice dent in his electric bill. I'm Scott Brown, Green Wind and Other Home Energies. I'm fixing to go hook up the ground over here on this other box. Maybe I'll take a little shot of video for that.